In this video, we are going to be looking at factorization. So, a brief recap, we are going to look at factorization basing on what we've already covered. We've looked at expansion of brackets. Now we're going to look at the opposite. Look at this one, for example, 2 bracket 4x plus 3. To expand it, we're going to multiply 2 and 4x and also multiply the 2 with the 3. So these 2, because it is outside of the bracket, means it's going to approach or multiply every term in the bracket, multiplied by 4x and also add 2 multiplied by 3. Then here we get 8x plus 6. So this is what we were doing when we were looking at expansion of brackets. So what do you see here? What's the commonality between 8x and 6? Okay, so if you can see here, there's 8 and there's 6. These are multiples of 2. Okay, if you look at the brackets here, you can see there's a 2 in the first bracket, a 2 in the second bracket. That 2 is the common factor. So this is the 2 in which we had as the coefficient of the brackets in the first problem. This is why when we expand, we get our answer as 8x plus 6. The important thing when factorizing is to appreciate or to look for common factors. Alright? Like if you look in this example, there is 2 multiplying everything. So the common factor here is 2 multiplying 4x and multiplying the 3. So 2 is the common factor. That's the one which we factor out. Okay, let's try another example and see. Okay, so we continue. Factorize the following. In this one, I'm going to give you the expression 2x plus 12. 2x plus 12. So it's very simple to factorize this one. The most important thing is to look for the common factors. You look at 2x and 12. So the common factor there, you need to break down the number into parts. Alright? 2x can be written as 2 multiplied by x, and 12 can also be written as 2 multiplied by 6. Alright? So what is the common factor now there? The common factor, there is a 2 this side and there's a 2 the other side. So 2 is the common factor. We write it outside the brackets. Then we add the remaining factors, x, and then plus, maintain the sign, 6. So our answer is therefore 2 bracket x plus 6. Alright, let's try the next one. 3x plus 15. Who wants to try? So here what we'll do is we're going to express 3x as 3 times x and 15 as 3 times 5. Right, and then we factor out the 3, which is the common factor. The 3 here, 3 there, it's common, and then we add the remaining factors, x plus 5. Next problem, let's look at the next problem now. 5y minus 15. Alright, so to solve this, we look for the common factor, which is 5. Then we're going to say 5 multiplied by y. And then we subtract 5 multiplied by 3. So our common factor there is 5. So we're going to factor 5 out and write 5. Then in brackets we're going to get the remainders y minus 3. So that will be our final answer there. Let's look at the example. Next one, 4y minus 28. So in this example now, we are going to factor out 4, so it's going to be 4 multiplied by y minus 4 multiplied by 7. You see that we looked for a common factor which can be factor of both this 28 and this 4y, and it is 4. So we factor out the 4 and then right outside the bracket, it's going to be 4. 4 bracket y minus 7. So that will be our factorized form. Right, let's continue to look at the examples. So now we want to look at how we can factorize powers higher than 1. Factorizing powers higher than 1. we're only looking at the powers of x, or of the unknown only being 1. Now we want to look at how we can factorize if there are powers of x higher than 1. Alright, so 3x squared plus 3 plus 15x, we can break it down to 3 multiplied by x multiplied by x plus 3 multiplied by 5 multiplied by x. In this way it will be easier to solve because we've broken down the problem. Now we need to isolate common factors from both the expressions in the brackets. So here we can see that we have a 3 this side, and also in an x we have a 3 this side and an x. So we can also see here that there's a 3 and an x on the other side. Alright, so we factor out the 3 and we also factor out the x, and we multiply them together, and what will remain are the x and the 5, which we are going to add in the last step. So our answer will be, we have something like 3, this 3 and this x as the common factors, which we will say 3x, multiplying or putting in brackets. So we cross out those ones which we've factored out. The remaining factors are x and positive 5. So our factorized form will be 3x bracket x plus 5. Alright, that is easy enough, right? The next example, 4x squared plus 12x. Again, the trick here is to find some apparent commonality before you even attack the problem. You can see here that there's 4 here and there's 12. These are both multiples of 4.
Break it down to its smallest, but here we can already see that we don't need to multiply 2 by 2 because the highest common factor here is 4. So now we need to break it down like this. It's going to be 4 multiplied by x multiplied by x plus 4 multiplied by 3 multiplied by x. Right? Let's think way up to this stage. Then this 4, there's a 4 here, there's a 4 there. So it means amongst our common factors, there's a 4. There's an x here, there's an x there, which means an x is outside of the brackets. No further x this side, no further 3 this side. So it means we add. Close out the common factors, 4, 4, x, x. We remain with x plus 3. X plus 3. Factorize like this. Let it be like example C. 4a plus 8ab. Factorizing something like this is very, very simple. You can already see in our mind's eye that is about 4. So we can factorize this with 4 multiplied by 3 multiplied by a plus 4 multiplied by 2 multiplied by a multiplied by b, like this. In my mind's eye, I can almost see what's happening here. There's a common factor 4 there, so the answer is going to be 4. There's an a here, there's an a there, right? There's another common factor. No more common factors, so the remaining factors will be 3 plus 2 multiplied by b, which is 2.
Alright, then we move on to our next example. So we're going to have the last example. 3e squared plus 4e plus ef. So you can see that e is appearing in all equations. We break it down: 3 times e plus 4 times e plus e times f. Alright, we can see here in our expanded expression we do not have 3's in other expressions or 4's, but we only have e. We have e and e there. So we factor out e, cross it out. Then we are left with 3e plus 4 plus f. And that is the end.
Right.
Don't forget to comment, like and subscribe. Enjoy. See you in the next video. Hello, welcome. In this video we are going to look at factorization and then later on move on to solving, constructing and solving equations. So sit tight and enjoy. If you've got any questions, please feel free to ask in the comment below. Don't forget to subscribe.
Second one is 4 bracket factorize each expression. So this is 8a, b, c, and d. C, g. This is 9a. Say the x plus f. Right? The common factor
Christmas tree's on fire. Santa's holding a lighter. My parents are both liars. I got gifts but 1 subscribers. Thanks for the candy basket. Oh, got another jacket. My stocking's filled with acid. Am I dreaming? What just happened? This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. My neighbors compete to see who can put up more blinding lights. The kids all wish away the month 'cause they want presents inside. This year had me so mad. I've been bad, got cold hat is sitting under my tree. I think that my Christmas has died. This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. This is not a Christmas. This is not a Christmas song. When I was just a boy, Christmas brought so much joy. Couldn't wait for the presents and laughter. I couldn't sleep late at night, looking for Santa with lights. Those are the memories I still remember. Then I became a man, lost sight of who I am. But right in front of me was the answer. 'Cause on Christmas I feel joy, and I turn back to a boy. The answer is just
Okay, so here you notice that, for example, this question 8a bracket 2a plus 1, 4a and 4a plus 2 in brackets will not work because there's still some commonality, which means you need to take the highest common factor, which is 8. So you need to take 8. If you write it like this, 4a bracket 4a plus 2 is not correct because 4a and 2, they still have some commonality, a common factor between them, which is 2. So you need to factor out that 2 again, multiply it by 4, and you get your 8. Alright, so take note of that to use the highest common factor. Okay, let's move on. So here we see that the common factor was 7c. So we write 7c bracket 2d minus 1. In the second, we see the common factor was 4a. So we write 4a bracket 3 plus 2b. In the third one, we have the common factor being 3g. We multiply by 7 plus 5h. Alright. 3g bracket 7 plus 5h. And then the fourth one, the factorized version was 15w bracket 2 minus t. Alright. So these are the solutions for problems that we have up to now. You can see here that there's no h here, so it would mean that in the solution we do not need to add an h.
Yes. But last time I said that if we have 1 as a coefficient of an unknown, we might as well know it. And let's move on to number 11, the last one.
Alright, so we're going to swiftly move forward.
Copy and complete each factorization. 11.
Okay, so we move on to number 11a. The first one was 2a plus 4h plus 8. The second one was 5b minus 25 plus 5j. C 12tu plus 16u minus 20. Okay, then for D it was 3e squared plus 4e plus ef. And E 7k minus k squared minus ak. And then the last one was 6n squared minus 9n minus 3mn. We'll go to the solutions now.
Yes, common factor was 2. D, common factor was E, bracket 3e plus 4 plus f. For E, the common factor was K, bracket 7 minus K minus 8. Then F, common factor here was 3n, bracket 2n minus 3 plus n. Right.
Alright, now we're going to look at constructing and solving equations. Constructing and solving equations. Right? So in order for us to construct and solve equations, we must be able to be in a point to be able to separate them from expressions which we were doing before. So here are some things to remember when we are working with equations. We've looked at expressions before. Now we need to see if there's a difference between equations and formula and expressions. So a formula is a rule. Formula is a rule. A formula is a rule which shows the relationship between two or more variables or unknowns or quantities. Must have an equal sign and must have an equal sign. So this shows that you have a formula. It must have an equal sign. Alright. A classic example would be the formula for finding the force exerted by an object, which is given by the formula force equals to mass multiplied by acceleration, of which, whilst on Earth the acceleration due to gravity would be 10 meters per second squared. The formula can be summarized as F equals to ma, force equals to mass multiplied by acceleration. On the Earth, the formula is F is equals to mass times 10 because we round off the acceleration due to gravity to 10. On the Moon, it is 1.6 meters per second squared. So it will be any mass times 10 meters per second squared. 10 meters per second squared. So this is the formula which we use for calculating the force. Right? Alright. So next we want to look at expressions. An expression is a statement. An expression is a statement which involves one or more variables. Okay? It may have maybe just terms in x or terms in x and y, that's one or more variables. But the other thing to note is that it does not have an equal sign. It does not have an equal sign. So an expression is just any general statement. A squared plus 2b, 3x minus 7, 2x plus 1, or the one which I'm going to write here, 2x plus 3. 2x plus 3 is an example of an expression. It has got one unknown term which is x, and it has got another term 3 which is a constant. Alright, so let's move on. When we talk about equations now, it is an expression. An equation is an expression that has two or more unknowns and also has an equal sign. The major differentiating factor or differentiating factor between an equation and the formula is that the equation can actually be solved to find the value of the unknown number. So an equation is an expression with an equal sign and can be solved to find the value of the unknown. In this case, let's say for example, 2x plus 3 equals to 0. Right? So to solve this is very simple. It's a very simple equation, 2x plus 3. A very simple equation. So you notice that even if the formula is an equal sign and two or more unknowns, yet the problem is that it has got, these unknowns do not have values, they have got assigned values. Whereas in equation, the unknown actually has a known value. The only thing which we need to do is to calculate the value of the unknown. Okay? So when we have equations, we say that we want to solve the equation to find the value of the unknown. So we say we solve for x or solve for y or whatever the unknown is, solve for x. Whereas in a formula, we need to assign it values. Let's say for example, calculate the force when the mass is given this number and the acceleration is given this number. In contrary to equations where we just you have to solve and find the value of the unknown, which is
Let's move on to try out a few examples.
So here I'm going to write the equation. I'm going to write my equation which we will need to solve here. We're going to try it out together. Alright, so as soon as I'm done writing, we'll work it out together.
Now, take note. In solving equations, we need to follow steps. Okay?
We need to have a methodical way of doing it. Alright, so in this example, we have 3x plus 5 is equals to 26. So what we will need to do is...
So for us to solve this problem, we first need to have one side, we need to bring like terms together. All terms with x on one side, all terms without x on the other side.
To do that, we subtracted 5 from both sides. 5 from both sides. That's what we did. So that our equation remains balanced. Now we have 3x plus 5 minus 5 is equals to 26 minus 5.
For all information, this cannot add or subtract. Why? Therefore, difference is in the unknown. This is x to the power 1, this is y 0. So we cannot work them out. Right. So 5 minus 5 is that 0. So this will be 3x is equal to 26 minus 5, 21. When we get to this stage, what do we do? Since the coefficient of x is 3, we're going to divide both sides by 3. So I'm going to say divide by both sides.
21 divided by 3 is 7.
So 3 to 3, 1, 3 to 3, 3 to 3, 3 to 3, 1, 7. So x is equal to 7. This is the solution to the problem. Minus means is if we substitute this x into this equation, the left hand side is equal to the right hand side. Right. So I want to explain why we're substituting the right hand side. This is an equation, right? An equation means that it's very simple and it's balanced on both sides. Okay? This is now, if we want to maintain this balance, if we add kilograms on the left side, what should we do on the right to maintain balance? Yes, also add 2, right? If we want to keep it balanced, we subtract 5 from the left side. What do we do on the right side? Yes. So this is why we are treating our equation like this. We want to maintain its equality, right? So if we subtract 5 from the left side, also subtract 5 from the right side of the equal side. If we divide by 3 on the left side, we also divide by 2 on the right side. Whatever we do on the left hand side, we also do on the right side to maintain its equality.
So we are going to look. Hello everyone, welcome. In this video we are going to be looking at factorization. So a brief recap, we are going to look at factorization basing on what we've already covered. We've looked at expansion of brackets. Now we're going to look at the opposite. Look at this one, for example 2 bracket 4x plus 3. To expand it, we're going to multiply 2 and 4x and also multiply the 2 with the 3. So these 2, because it is outside of the bracket, it means it's going to approach multiply every term in the bracket, multiplied by 4x and also add 2 multiplied by 3. Then here we get 8x plus 6. So this is what we were doing when we were looking at expansion of brackets. So what do you see here? What's the commonality between 8x and 6? Okay, so if you can see here, there's 8 and there's 6. These are multiples of 2. Okay, if you look at the brackets here, you can see there's a 2 in the first bracket, a 2 in the second bracket. That 2 is the common factor. So this is the 2 in which we had as the coefficient of the brackets in the first problem. This is why when we expand, we get our answer as 8x plus 6. The important thing when factorizing is to appreciate or to look for common factors. Alright? Like if you look at this example, there is 2 multiplying everything. So if the common factor here is 2 multiplying 4x and multiplying the 3. So 2 is the common factor. That's the one which we factor out. Okay, let's try another example and see.